I'm going to show you how to convert a binary number directly into a hexadecimal number. Until now in this course, you were forced to convert binary numbers, such as this one, into a decimal number, which took a lot of work. And then that decimal number, with even more work, could be translated into a hexadecimal number using the techniques that I taught you in the last couple days in class and that are found in my lecture notes. Well, I'm now going to show you a direct way to convert from binary to hex. Follow along. By grouping each set of 4 bits, starting from right to left, and putting a little space in between the groups of 4 bits, you can label the columns with our typical powers of 2, 1, 2, 4, 8, but then instead of going to 16, 32, 64, 128, repeat the powers of 2 up from 1 to 8 for each set of 4 bits, and then it becomes very easy. Anywhere that you see a 1, take that label and add it. That's a total of 13. Here we have a 1 here and here, so they add up to 3. Here we have a 1 in the 8's column and a 1 in the 2's column, so that adds up to 10. And now in your final hex converted number, you know that for each group of 4 bits, it ends up being a different hexadecimal digit. And this 10 converts in hex to the letter A, and the 3 remains to be a 3, and 13 in hex is a D. And there you have it. You don't have to change the binary number into a base 10 number and then change base 10 to base 16. By grouping these bits into groups of 4, it always works out to, in a straightforward way, convert each 4 bits into a corresponding hex digit. To do this with a octal number, it's just a slight variation. Let's just do it real quickly here. If I gave you the same binary number and I wanted you to convert it to an octal number, well, instead of grouping these in 4 bits, from right to left, group the bits. Okay, this one, these 3 ones would be in the next chunk of 3 bits. So 0, 0, 1. And we have these 3, 0, 1, 1. If you have to, you would pad the front with 0 so that you have groups of 3 bits. I think you see where I'm going with this. Now you label these columns instead of 1, 2, 4, 8, 16, etc. You repeat the 1, 2, 4 above each group of 3 bits. And everywhere that there's a 1, just as you did in the exercise up above, 4 plus 2 here simplifies to 6. This 1 simply leads to a 4. All 3 of these ones, this group of 3 adds up to 7, and we have a 2 here. So there you go. Because there were 4 groups of 3, we know that we have 4 digits in our octal answer, and there is the number as it would convert to octal. Now let's say you wanted to go the other direction. Let's pretend that you didn't know what 6472 in octal translated to in binary. Without changing to decimal and then taking decimal and changing it to binary in this case, we can go directly. Just take each of these digits and realize that each digit expands into 3 bits, since this is an octal number. And you make change, as I call it. If I gave you only $1 bills, $2 bills, and $3 bills, or I'm sorry, $1 bills, $2 bills, and $4 bills, if I only gave you those types of bills, how could you come up with a number 2 by those 3 types of monetary bills? Well, 2 would mean that there's a 1 there. You do not need any $4 bills or any $1 bills. So in your final answer over here, it's going to end with 0, 1, 0. How do we get a 7 out of a 4, a 2, and a 1? Well, 4 plus 2 plus 1 is 7, so we need one of each of those 3 bills, as you would think of it. And here, to get a 4, from a 4, a 2, and a 1, I guess we just need a 1 there and 2 zeros. So our final answer is taking shape over here to the right. And the number 6 there, using a 4, a 2, and a 1, you need a 1 of these and 1 of those. 4 plus 2 is 6, and 0 $1 bills. So 1, 1, 0. There is your binary value that's equivalent to this octal number. It's the same problem, but just reverse of this. If we're going from hex to binary, keep in mind that each hex digit will end up being represented as 4 bits in our final answer. So in this case, we have a total of 12 bits in the binary value that we want. This is base 16, of course. The an A is equivalent to 10 in decimal. And if you had 1s, 2s, 4s, and $8 bills, how could you make change or make it so that you have $10 total? Well, a 1 there and a 1 there. 8 plus 2 is 10. Pad this with zeros. The 3, how do you make a 3 with an 8, a 4, a 2, and a 1? Well, I guess you need 1, 2, and 1, 1. Padding with zeros. And how do we make a D? Well, D is really the number 13. And this number 13, when created with a combination of 8s, 4s, 2s, and 1s, you would need, let's see, an 8, a 4, and a 1. Pad that with a 0, and there is your answer. It's the reverse of the problem that we did up here. Good luck in the future converting directly from binary to octal or hex, and converting directly from octal or hex into binary. This saves you time on the AP exam if you have a question like this rather than dealing with base 10, the decimal system.